Hey folks, I'm Mr. Hartzler, and I want to talk to you in this video about some trigonometric stuff or trigonometry stuff. So we're talking about trigonometric functions and acute angles. You'll see me looking down some, and that's looking at some of my notes and the textbook that I'm kind of basing a lot of this stuff off of. This is going to be for my students. They're starting trigonometry in Algebra 2, but they're starting it at home right now. I'm creating this because of coronavirus or COVID-19 or SARS-CoV-2, however you want to name it. But that's what this video is going to be about, is trigonometry, and I just said why I'm making it. All right, first thing I want to do is share my screen with you. So we're going to bring up the whiteboard. I'm using Zoom to do this, by the way. Zoom's been pretty stinking awesome for me so far. I have done a lot with it. It's how I communicate with my students and how I'm making some of these videos while at home. All right, so for me, this is section 7.1. But in any case, we're talking about introduction to trig. And the first thing I want to talk to you about is our ratios. So let's draw a little triangle here. All right, it's not great. I'm using a drawing tablet here so I can show some stuff online. But again, not pretty drawings all the time. And we need an angle of reference. So we're going to have this be our angle of reference. That little symbol is theta. I'm actually going to redraw it so that at least once you can see it all nice and pretty. So it's like a 0 with a squiggle in it, theta. So that's a Greek letter. And now I'm going to label some of these. So everything is in relationship to that theta. So the side opposite of it, I call opposite. The side next to, I'm going to call adjacent. Okay, adjacent just means next to. Like if my house were adjacent to yours, we'd be neighbors, right? We would live right next to each other. Not necessarily on the left or on the right. It could also mean across the street or across the thing, like diagonal. It just means next to, and that doesn't particularly mean anywhere around. So keeping in mind, though, I am directly next to in some way, shape, or form. Opposite leg, this is definitely not next to this one at all. And you could argue that this side here, I believe you can see my mouse there, that is also adjacent, but we would also call this hypotenuse. So we call that the hypotenuse, like we've always done, but we have kind of a new name with the adjacent and the opposite going on here. Now, in reference to this, we have a bunch of new vocabulary words. So we have, or am I going to write it? I'm going to write it over here. We have sine, S-I-N-E. We abbreviate it typically by just dropping off the E, and we write sine of our angle, or of theta, and that is equal to our opposite leg divided by our hypotenuse. So I'm not going to write the whole word. If you know me, you know that I say often that people that love math love being lazy efficiently. So hype is plenty good enough to have you know that I'm talking about hypotenuse. Sine theta is equal to opposite over hypotenuse. It's always that ratio every single time. Our angle might change, but as long as we're using our opposite and hypotenuse, this is all going to be true. Now let's talk about cosine. So again, we like being lazy in math, so I'm just going to write cos of theta. And that is our adjacent over hypotenuse. And we also have one that is tangent. Remember, tangent means touching at just one spot. So if I had a circle, then I had a line, it would be just touching at one spot. But here it is a little bit different, right? We're still a ratio, we'll call it tan theta of opposite over adjacent. So this one is kind of cool because it's also sine theta over cosine theta. So that's kind of the nice thing there. I really only need to know sine and cosine. I'll put a little asterisk there, because if I know those two, I can derive my tangent function, or I can create it using the other two. So again, these are all ratios related to the angles and their corresponding legs, okay? We do have three more, though. These are called reciprocal tangent functions. So I have cosecant. I write that as SC theta. and that equals my hypotenuse over my opposite. So it's reciprocal function because you'll notice here opposite over hypotenuse, and then hypotenuse over opposite. Sine and cosecant are inverses of each other, are reciprocals of each other. Cosine has secant, and it's SEC. Theta, of course, don't forget your theta. And that is our hypotenuse over adjacent. So that's kind of exciting. And then tangent, we have cotangent. Oh, I shouldn't have that N in there. Let's try that again. Cotangent. Oh, no, tangent, yeah. It is with an N. All right, and we have, that's just COT of theta is adjacent over opposite, or it's now cosine theta over sine theta. A lot of people forget that part of both tangent and cotangent, and that is incredibly helpful to remember that it is sine over cosine or cosine over sine. So I want to give you a little mnemonic device maybe to help you out. I remember this like soh ka toa. Soh ka toa. I definitely try and emphasize the H's, otherwise you don't know what's happening. Soh ka toa. And that helps you remember sine, cosine, and tangent. So sine here is opposite over hypotenuse. That's what our O and then our H are. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And of course, the reciprocal functions are just the reciprocal of that. I also remember this in another way. Don't know if it's helpful for you or not, but I'm going to share it anyway. So if I'm looking at sine, I'm starting there, and I'm going to go through sine, cosine, and then tangent. Oscar had a hold on Arthur. That's another way to remember it. Or there was a really cool one. One hobo, or no, some old hobo caught another hobo tripping on acid. That's what it is. So that's one, if you want to be a little more interesting with life. That one includes the sine, cosine, and tangent part. So I'll try and highlight those as I go. Where's my mouse? There it is. Some old hobo caught another hobo tripping on acid. So that was one I learned from another math teacher at the school I teach at. And I thought that was kind of fun. So there's that. That's kind of cool. All right. So I'm going to now save this picture. Now we're going to clear the board, everybody. Clear all drawings and flip the page of my notes. Let's do an example with this. So I'm going to switch colors up a little bit. Let's, I guess I'll stick with black, but I'm going to make it a little more bold. All right. So I'm going to draw myself a triangle. We're going to pretend for a moment that this is a right triangle. And I'm going to know that because of my little 90-degree angle here, right? We're going to put our angle up here. There we go. I am now going to make my size a little bit narrower. How did I just edit my size a second ago? Oh, there it is. Change my width to be a little bit skinnier so I don't take up as much space with this. So I have 20 on this side. I have 21 over here, and I have 29 for my hypotenuse. Remember, this is my height. This is my, over here, the 21, that is my opposite. 20 is my adjacent. So now we're just going to set up all of our trig ratios. I'm going to start off by writing so, ka, toa, the top of my paper. Say it more, you remember it better. All right. So sine of my angle, remember this is always in reference to this particular angle, to whatever one I've labeled. So in this case, it's up in my top left. But if it were my bottom right, all I have to do then is change what's opposite, what's adjacent. The numbers don't change that way. Okay. So sine is my opposite over hypotenuse. What is opposite of the angle? Well, that's going to be the 21 over there. 21 over, I need to now erase that arrow. What is hypotenuse? Well, that's 29. All right, so sine of my angle is going to equal 21 over 29. That's what that ratio is going to be. cosine of my angle, adjacent over hypotenuse. So it's going to be 20 over 29. Now we're looking at tangent of my angle. That is sine over cosine, or TOA, opposite over adjacent. So 21 over 20. Pretty cool, right? I know. Now let's go over and let's do those reciprocal functions. So we have cosecant, sorry. Cosecant of theta equals, it's going to be the reciprocal of sine. So it's going to be now 29 over 21. And then we have secant of theta is going to be the reciprocal of cosine. So that's 29 over 20. And cotangent theta is going to be 20 over 21. Exciting. I know, just riveting. You just can't even contain your excitement, I understand. All right, so let's find some other information here. So first I'm going to save this. Let's clear the board, all right? Clearing all things. So let us use one trigonometric ratio to find all of the others. So this is going to be where things are a little bit different. We are going to make this the problem. So knowing that tangent of theta equals 15 over 8, what are the other 5 trigonometric identities? Our trigonometric ratios. So I know tangent. I'm going to build a triangle off of that. Again, not to scale, not even somewhat pretty. Tangent is TOA, so opposite over adjacent. I need to pick one of these angles to be my reference. So I'm just going to pick that one. It does not matter which one it is. So opposite of the theta is going to be the 15. So opposite is 15. Adjacent, or next to, is going to be 8. Well, how do I find out how long my hypotenuse is? Obviously, Pythagorean Theorem, right? Keep in mind, you can only do Pythagorean Theorem if it is a right triangle. So 15 squared plus 8 squared equals my hypotenuse squared. I'm going to cheat, look at my notes, but I am pretty confident y'all can do this. That answer is 17. So it's no longer a question mark. It's now 17. Sweet, right? Okay, so now we are going to find all of our other trig ratios. So let's look at sine of our angle. Again, I picked it arbitrarily, but now this is all correct, right? I use this as my reference angle, theta, and I built everything off of that. So sine is S-O-H, so opposite over hypotenuse. So it's going to be the 15 over 17. Cosine theta is adjacent, over hypotenuse. So adjacent to my angle is 8, hypotenuse is 17. Already done tangent. So now I can find the other ones pretty easy, right? Cosecant theta is the reciprocal of sine. So that's 17 over 15. Reciprocal of cosine is secant, and that's a 17 over 8. How I remember whether cosecant goes to sine or cosine or whatever is cosine and secant are kind of the same, but spelled backwards. I don't know if that's helpful for you, but it is for me. COS for cosine, SEC for secant, and those two are connected. While I can't find any good similarities between sine and cosecant letter-wise. So that's how I do it. Maybe it's helpful for you. Maybe not. I don't care. All right, and we need to do cotangent. Cotangent theta is going to be the reciprocal of tangent, and since tangent was 15 over 8, this is 8 over 15. Awesome. I think we're doing great. I'm feeling pretty good about this. Let us clear our board. And I'm going to skip a word problem for right now, right? I don't think we're there yet. But let's discuss this. So some of this has to do with geometry, which some of my students haven't taken. So in our school, a lot of honor students take Algebra 1, then they go into Algebra 2, then they take geometry. But I don't think this geometry is too challenging, so we're going to start off here with another triangle. There's a triangle. And let us say that this is a 45, 45, 45. Sorry, 45. Erase. Try again. 45, 45, 90 triangle. So that means this angle here is 45. This angle up here is 45. This one is obviously 90. And these are all in degrees. I didn't write my degree symbol. Okay. So this is a 45, 45, 90 triangle. And I know that this side over here is a 2. Well, some common geometry would tell you that if one side is 2, the other side is 2. And I don't mean the hypotenuse. So 45 degrees is opposite of the 2. Well, if this other angle is 45 degrees, then it's also opposite of a 2. I'm actually going to do that in a different color here, because it is important to note that that they're the same and why. So it's because it's a 45, 45, 90 triangle. Now that I have two sides, what can I do? Well, I can find the hypotenuse now just using some simple Pythagorean theorem, right? 2 squared plus the 2 squared equals my hypotenuse squared. That's going to result in a different color here. Let's see, it's a 2 square root of 2. 2 square root of 2. The fun thing is, if I scale this up, these numbers are going to hold true every single time, no matter what. As long as it's a 45, 45, 90 triangle, I know. Let's actually draw another one over here. I'll do this one like a brown, burgundy. I don't know what color this is. All right, it's a 90. That's a 45. That's a 45. And let us say that this side length here is A. Well, then I know for a fact this other side must be A as well. And as we kind of just showed, this side over here is going to be A times the square root of 2. That's just how the Pythagorean theorem is going to work out. You can just do it on your own if you want, but this is, I don't know how long it is, but this is already getting to be a long video. So I'm going to skip that part. But using this, we can then find all of our other stuff. So sine of my angle, well, it's sine of, let's do 45 in this case. And 45, so it's opposite of sine, right? Because so opposite is going to be 2 over 2 square root of 2. All right, this simplifies a little bit, right? It's going to simplify to 1 over square root of 2. But we don't like square roots in the denominator. It's really just because the denominator, we want to try and make it common with other things, and that's really hard with the square root involved. I don't know what to tell you. Some lonely person a long time ago didn't think it looked pretty. We try and make things look pretty sometimes. So I'm going to rationalize this. I'm going to rationalize. So I'm going to multiply by a square root of 2 over square root of 2. Remember, square root of 2 divided by square root of 2 is a fancy 1. I'm allowed to multiply by 1 as many times as I would like. This is just a weird looking 1. So now, let us go to, I'll go to black. All right. So the numerator is now 1 times square root of 2 is it's a square root of 2. I can just add my square root. Square root of 2 times square root of 2 is square root of 4 or normal 2. Nice. Good job. So sine of 45 is a square root of 2 over normal 2. Let's look at cosine of theta or cosine of 45. Well, cosine is kach or adjacent over hypotenuse. And by a similar logic as to sine, we end up with square root of 2 over 2. And tangent, I'm going to do tangent over here. Tangent of 45 is a little bit different, right? It's toa, opposite over adjacent. So that's a 2 over a 2, which simplifies to 1. I know, it's magical. Makes me feel nice too. All right. That is a 45, 45, 90 triangle. I'm going to save this page and let's clear it all away. We have another kind of triangle that is incredibly important. And that is a 30, 60, 90. So this one up here is going to be, actually, I need to draw this differently. All right, let us go here. I'm going to make this bolder. We're going to draw an equilateral triangle. So that means all sides are equal. And let us do a little dividing line down the middle, right? Because I've told you a lot of the stuff we've done is only going to be right triangles for a little while. So again, this is an equilateral, so all my angles are 60s, which means this up here now, since I cut it in half or bisected it, is 30 degrees. Awesome. Okay, we're doing all right so far. And let us say that each side length was 2. So this is still a 2. So that means this side down here is 1. And I have to use Pythagorean Theorem to find my missing chunk there, right? So I have 2 squared is going to equal 1 squared plus, let's do things in reference to the 60-degree angle right now. That's what my theta is going to be. Theta. All right. So I'm going to write opposite leg squared. So 1 squared is just 1, 2 squared is 4. So I get 3 equals opposite leg squared. So if I square root both sides, I have a square root of 3 equals opposite. Okay. I am going to leave that as red. So in here, square root of 3 for my opposite leg. Now, let us find what sine of 60 is. Sine of 60 degrees. Remember, sine is soch, opposite. So square root of 3 over hypotenuse. Cosine 60 degrees. Kach, adjacent over hypotenuse. So that's going to be a 1 over 2. Adjacent over hypotenuse. Tangent 60 degrees. So that's an ugly 6. I'm going to do this one a little bit differently. I'm going to do it as square root of 3 over 2 divided by 1 over 2, right? I'm doing sine divided by cosine. A lot of my students remember this as keep, change, flip. So I keep the numerator the same. I change division to multiplication, and I flip or do the reciprocal of my denominator. So now I have square root of 3 divided by 2 times 2 over 1. These 2's, I'm going to change my color here because they cancel. So this is cross simplification, if you want to think about it like that. So square root of 3 over 1, or just a square root of 3. Similarly, if we change where theta is, and we now say that it's up here at my 30-degree angle, sine of 30 ends up being 1 over 2. Cosine 30 is, not a 1, a square root of 3 over 2. And tangent 30 ends up being square root of 3 over 3. And that is because we have to rationalize that. Actually ends up being 1 over square root of 3, then we rationalize. All right, so I want to show you a cute little table. And I'm going to clear all of this. I like this table. I think it's helpful for me to remember stuff by. I'm going to make this here. We have 1, 2, 3, 4 lines. That one. That one. Super trippy doing this on a little drawing tablet here. Got to look at my screen, do the drawing on essentially a giant trackpad. It's weird. Okay. So now I'm going to get a thinner line again. This is going to be 30 degrees. Here's going to be 45 degrees. And here's 60 degrees. This is going to be sine of my angle. So I'm actually not going to write theta there. No, I'll leave theta there. And then we have cosine theta, and we have tangent theta. We've talked a while ago now about the reciprocal of all of these functions. So I'm not going to worry about those. If you know sine, cosine, and tangent, you can find everything else. And really, if you know sine and cosine, you can derive tangent. So you're okay. I remember this by first putting in fraction bars for all of these. I'm just going to do it for sine right now. Sine goes 1, 2, 3. And it's actually the square root of 3 and the square root of 2. What's the square root of 1? Still just 1? Yeah, good job. And we're dividing all of those by 2. So sine of 30 degrees, no matter what length the legs in the hypotenuse are to the triangle, sine of any 30-degree angle is going to be 1 over 2 every single time. It's awesome that way because it's the ratio of those side lengths. And the ratio, no matter how big it is going to have is going to simplify to 1/2. So that's really cool. And then the same for 45 and 60 degrees. So 1/2 square root of 2 over 2, square root of 3 over 2. Cosine is, I'm going to say the opposite, but it just goes in a different order. So again, there are fractions for each of these. Cosine starts at square root of 3, and then goes to square root of 2, and then goes to square root of 1, which is just 1. And my denominators are still just halves. I'm telling you, my student, memorize this table. Not just for my class, but for when you get to geometry and you do trig again there. When you get to pre-cal and you do some trig there. And when you go to calculus and you do trig there. For the rest of your life, as long as you stick with math, memorize this table. It's not that bad, right? Sine, 1, 2, 3. Cosine, 3, 2, 1. Square root everything in the numerator, everything's over 2. Tangent, remember, is sine divided by cosine. So if I look at these, my 2's are going to cancel. And I'm left with a 1 over square root of 3. Talked about a second ago. If you rationalize that, you have square root of 3 over 3. For 45, sine and cosine are the same. So if two things that are the same, if I divide them by each other, I end up with 1. And then over here, square root of 3 over 2 divided by, right, because sine over cosine, 1 over 2 gets me just a straight up square root of 3. So tangent gets bigger as it goes up. It's kind of exciting. So I'm going to save this table. And where are we at? All right. I think actually we're good. I think that's the end of this video. I think that's all I really needed to show you. So I'm going to end my screen share. And I just want to tell all of you that if you like this video, please click that like button. It should be down over here somewhere, I think. And subscribe to the channel if you want to see more like this. If you're one of my students, please do not hesitate to email me. I would love to answer all of your questions. If you're somebody else and this was helpful, please click that like button. It helps me to know that someone else has found it and I found it useful. And please comment below if you have any questions or if I made a mistake or an error, or if you just have a comment that you think is worth me knowing, right? So if you like the video, say why you like the video. If you didn't like the video, tell me why. That way I can make improvements for the future. Without having your feedback, I don't know. And also without your likes and without your views, I don't know if this video is even worth watching. So check it out and comment if you have any comments or suggestions or questions or anything at all. I hope everybody's doing well out there. Make sure you keep doing math carefully and with enthusiasm. Bye, everybody.